Hey guys, this is Rick. So last week's video on the Lightning Network generated a lot of discussion. And I have to admit, some of that discussion was quite productive. And as it turns out, I was slightly off on just where the Lightning Network stands. In fact, it's much worse than I first thought. Let's take a look at why. So, a second look at the Lightning Network, following up from last Sunday. We were seeing this graph a lot last week, as we are talking about routing of payments from our system down here into our channel to a destination network somewhere up here. And as I illustrated, there were 4 problems with this. Those 4 problems were that routing was unsolved. You must be online to receive, which it was argued is less of a problem for web merchants because they must have their website online in the first place, which is a fair point. The legal liability for nodes, they're going to be subject to know your customer anti-money laundering regulations because you're locking funds up with them. And reactive security, like in IRC, doesn't work. But there was a very interesting discussion which followed this, specifically about routing. And following that discussion, I've come to realize that it is much, much worse than first thought, and which I presented. Remember, the Lightning Network is being marketed as the Internet of Money. The Internet of Money. So the idea being that since you can send a packet from point A to point B on the internet, you can also send money from point A to point B on the internet. In order to understand why this breaks down, we need to understand a little bit deeper how routing happens on the internet. How does routing happen on the internet? And in order to understand that in turn, we need to understand a little bit about layers, technology layers. On the internet, we have 3 relevant layers. We have your IP address, which looks something like this, assuming IPv4 addressing, which we're working with here. This address is tied to a physical interface, which has something called a MAC address, and which is installed at the factory. You can change the IP address, you cannot change the MAC address with a physical interface, which in turn is connected to a cable. The software aware of the IP address is aware of the physical interface through something called ARP, Address Resolution Protocol. We'll be returning to why this is important. It is absolutely crucial to understand how routing works on the internet. But let's illustrate with an example. Let's illustrate a package to a remote system. We are here at 192.168.0.42. That's a so-called private address. It doesn't exist up on the public internet. We want to send to this address. We got that address from looking up the domain name of something. So the first thing our software sees is that it is unable to send directly to the remote system because it is not in the same so-called subnet. The remote address does not have the same first numbers as our address, and therefore the package is handing over to a gateway with our internet service provider. This is where it obtains a public address for the first time. The internet service provider discovers that this is not in our network either. So it is handed over to the internet backbone. This is where something called the Border Gateway Protocol, BGP, takes over, and we'll be returning to that. The internet backbone consists of so-called autonomous systems. These are essentially internet service providers. There's about 60,000 autonomous systems who share 700,000 routing entries between them. And each and every single link between an autonomous system and another autonomous system is established manually, like a Lightning Network channel, if you will. And when we look up this IP address using the Border Gateway Protocol, we find that the address is in autonomous system number 51040, called the Pirate Party Autonomous System, because of course the Pirate Party has an autonomous system. And this is where a little bit of magic, if you like, takes place. Because this is where we need to start routing through the Border Gateway Protocol. And it's absolutely crucial to remember that this is a trusted system. The only reason we think that this IP address is on this autonomous system is because it says so. It says so. There is no security at all in this layer. Which is why you can have scenarios where one internet service provider, one autonomous system, decides to advertise, as it's called, that it is also serving Visa and MasterCard. Returning to this slide, a Russian autonomous system decided to advertise onto the Border Gateway Protocol internet-wide that all packets for Visa and MasterCard should come here. This is a trusted system. There cannot be any adversaries here. And then using BGP, it chooses the shortest route through to autonomous system number 51040. What the shortest route is and how that is determined depends on the number of factors. The easiest decision factor is the number of hops between where we are and the AES we want to get to. The shortest number of hops is the primary decision factor. There are many, many other decision factors, but just to give you an idea of what's involved in this decision. And once we hit the remote internet service provider and its entry gateway, we're going back to add the address resolution protocol, because all of a sudden we need to find where this address is in the remote ISP. And this is where this lookup table between IP addresses and what physical port they are on comes into play. And so the packet for this IP address is sent to a certain physical port, a certain MAC address, using lookup tables from ARP in the remote local layer network. This is how packet routing happens on the internet. And in every single one of these steps, the packet is handed over. This step does not know what came before here, does not know what comes after. It is just handed over, hop by hop. And just to give you an idea of how complex this system is, that in the internet at large, it's estimated now that 500 million new devices are added every month. Every month. The total number is approaching 50 billion connected devices. And out of these 50 billion, only 60,000, as we saw, are so-called core devices, routing points for an autonomous system on the internet backbone. So with this fresh in mind, let's go back to the Lightning Network and the Internet of Money. What you'll notice that this is advertised, this is sold as essentially a payment routing engine. This is what it is. A payment routing engine, a way to get our payment from here to there. That is the key innovation, the path discovery of getting from A to B. Everything else has already been solved. Getting a payment between two hops or between two stations that communicate directly, that's borderline trivial. The one key innovation for the so-called Lightning Network is this routing. So I'm laughing here because I know what's coming next. When you're looking at this 59-page white paper, and I'm not making that up, the white paper is 59 pages. You would expect that solving this particular problem, which is a really complex one, would take up a very large proportional amount of the white paper. When you search for routing and route in this 59-page white paper, you're getting this. This is all there is in the entire 59 pages about routing. And I'm going to break a golden rule, and I'm actually going to read this text of screen of text aloud. It is theoretically possible to build a route map implicitly from observing a transaction type on the blockchain to build a routing table. Note, however, that this is not feasible with another type of transaction, blah, 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 blah. Building a routing table will become necessary for large operators. For example, BGP, Border Gateway Protocol, CJDNS. Eventually, with optimizations, the network will look a lot like correspondent banking network or Tier 1 ISPs. Tier 1 ISPs, where BGP comes into play, the internet backbone we talked about. Similar to how packets still reach their destination on your home network connection, not all participants need to have a full routing table. The core Tier 1 routes can be online all the time, while nodes at the edges, such as average users, would be connected intermittently. Node discovery can occur along the edges by pre-selecting and offering partial routes to well-known nodes. Do you realize what a crock of shit this is? Do you realize that this doesn't even go into solving the problem of routing? This is when you're just dumbstruck and thinking, it cannot possibly be this bad. I'm sorry, but it can. And it is. And it's even worse. It's far worse. Let's summarize what we just saw here. It's theoretically possible to build a route map. No shit, Sherlock. Routing will be necessary for large nodes. Routing will look like the Border Gateway Protocol. This is blatantly false to begin with, because the Border Gateway Protocol, as we saw, is a trusted environment. It is a trusted environment. Lightning Network aspires to be trustless. It aspires that you can add adversarial nodes to it. So this is just plain wrong. And last but not least, all nodes don't need the full routing table. No, as in no shit Sherlock. If I'm holding an internet-connected device such as this, it doesn't need to be able to understand the exact path to every single one of the 50 billion other devices on the internet. This device doesn't need to know that. Conspicuously absent from this list of statements is anything at all about how this routing is supposed to bloody work. And it doesn't. Just to illustrate how audaciously lacking this is, compare this to if somebody had advertised an anti-gravity device. An anti-gravity device. And had a white paper, a 59-page white paper about how anti-gravity works. This would be the key section on how anti-gravity works, corresponding with the previous statements. It is theoretically possible to reverse gravity. Well, okay. a negative mass will be necessary for the heavy components of the system. This is when you start realizing that you had better start explaining how this is going to be achieved. But the white paper doesn't. Anti-gravity devices will appear to hover. They are just describing the routing result as might look something like BGP. Saying that you have an anti-gravity white paper and saying that the result will appear to hover is insultingly insufficient. And last but not least, all components don't need the negative mass. Lighter components can be carried by the system as a whole. All devices don't need the full routing table. This is so bad. What we just saw in this white paper is so incredibly insufficient and bad that nobody should get away with hand-waving this works and this'll work kind of hot air. Nobody should get away with that. So just to illustrate, how does routing work today? Because the Lightning Network is operational on the main network of Bitcoin. So how does routing work today? How does pathfinding work today? I'm sorry, but it doesn't. It really doesn't. It draws on another part of the white paper, which states this. This is an earlier summary, earlier in the white paper. One small paragraph, the key part of which is that the sender may designate a particular path. This device is required to know all the other 50 billion devices on the internet and the exact path to take to reach each and every one of them. Path discovery is left to the sender. Path discovery is left to the sender. This is the internet equivalent of not having packet handovers in the first place. This is the internet equivalent of putting the burden on the sender to find the entire path from this system to this system and instruct the very first hop the entire chain to follow. This is not routing. This is not an innovation. And the only thing we hear is that it'll work in a future release. No, it won't. It won't, and I'm going to tell you why it won't work. So far, it's been we illustrated why this is hot air and why the white paper doesn't even try. It doesn't even try to explain how the key innovation is going to work, which is frustrating to no end. There's some hand-waving about so-called onion routing. And when somebody says that the Lightning Network does onion routing, you need to understand that the onion routing is not actually path discovery. It is not path discovery. The onion routing technology is an anonymization technique, where you're preventing one hop from knowing the hop beyond the next or the previous. It is an anonymization technique. It is not the path discovery. This is bad. It gets worse. After last week's video, when we talked about this path discovery, user square root 7744 on Reddit pointed out that it is not enough to find a path. As we remember, this is essentially a transfer of IOUs through the system. If I want to transfer $5 to that person over there, then I'm shifting the balance of this IOU channel by $5, by this channel by $5, by this channel by $5, and so on, until the net end result is that I owe that person $5 more through the propagation of hops through the network. So as square root 7744 pointed out, it is not enough to find a path through the network. You have to find a path that has enough liquidity. Enough liquidity to cover the payment you want to do. It is not enough to find a set of channels that take you from point A to point B. They must also all have a balance higher than the $5 you want to send. And this is when you start to realize just what a mess this is from an engineering standpoint. Because this means that every single routing lookup needs to be parameterized. Just using a routing lookup, a fast routing lookup table, will no longer work because you need to also check if it has sufficient liquidity for every single lookup. It has a huge performance hit. And once you realize this, you start realizing just how bad it gets. Because this is where it goes really bad. And follow me now with this background. Since a route is dependent on having enough liquidity at every single hop, and every transaction in the network changes this liquidity by design, this means that every single transaction in the network is going to change the entire global routing table. Do you realize what a complexity this is? Do you realize how this cannot be hand-waved away? Do you realize that a white paper that talks of billions of transactions, where the entire routing table is reset on each of those transactions, is an exponentially harder problem than routing on the internet? Because on the internet, a packet sent from A to B cannot invalidate that route for the next packet along the same in the same source and destination. The Lightning Network claims to handle billions of transactions in an adversarial environment. And yet, on the internet, a flapping route in the BGP layer, the backbone layer, can take hours to stabilize. Hours. If a route goes up and down, it can literally take hours to make this route available or not available, and packets will be lost in the meantime. And this doesn't even start to address all the race conditions and concurrency problems that'll arise when somebody tries to use the same channel for the same liquidity twice. If two sources are trying to send to different destinations but going through the same channel, and both try to allocate the same liquidity, so one of them has to fail, or both. And by the way, the white paper does somewhat address this by saying that you can reverse a payment, but it only says use the same route or another route, or, this is my favorite part, wait for the entire transaction to time out, which might take a month, in which case the players will likely do this, and so it will probably come out okay. It's not even trying. I'm sorry, it's not even trying. So, in summary, the Lightning Network claims to solve routing for payments. The Lightning Network doesn't even try to solve routing for payments. And it has a routing problem, complexity, that far exceeds that of the internet. So just hand-waving about how this works because the internet works is insultingly insufficient. And the white paper doesn't even mention how it's supposed to work. It doesn't even attempt to explain how this is supposed to work. So concluding in the same way I did last week, this is a complete dead end.